Hello, everyone, and welcome to another episode of the Modern Biopharma Podcast. We have a new guest on today, Tobias Kuners of Koenders, and I'm sure I pronounced that wrong, but we're going to ask him to do that for us. We're going to talk today about Maintenance 4.0. Before we get started, just a little background. Tobias has more than 30 years of experience across multiple facets of operations, including project management, facility services, maintenance, engineering, validation, packaging, and supply chain management. Basically, he's done it all here in highly regulated industries. He's a managing consultant at Tobias Management, a Netherlands-based consulting firm providing business and technical expertise to the pharmaceutical, biotech, medical device, and FSMP, food for special medical purpose industries. So I'm going to ask this question first. Tobias, I'm certain I said your name the wrong way, so help me out here. How do we say it?
You did a great job there, but as a Dutch guy, I would say that my name is Tobias Kuners of Koenders. And the twist there is that the word "of" in Dutch means "or" in English, so that makes people choose either the first part, the Kuners, or the second part, the Koenders, where it's the full name. And for those that wonder, my blood is as blue as anybody, so there's no royalty in it. It's just a name that
All
most likely comes out of Germany, where people were uncertain how to write it, or the pronunciation back in the days when people spoke more regionally was confusing to them.
All right. So then what you just said, I didn't do that. You were way better at it than me, obviously. So I said Tobias. We got that right? We going with
Definitely.
Tobias?
Yes.
We got it. All right. Awesome. Well, before we get started, I'd like to just get to know everybody a little bit better on a personal level. And you just shared a little bit just based on your name. So thank you for that. But why don't we, just to get started, can you tell us a book maybe that you've read recently?
Well, recently I did. I've started in a new book that's called Dutch Light about Christiaan Huygens and the making of science in Europe. And Christiaan Huygens is obviously a man of science that did a lot of with light and with the microscope and with looking at the real small world. So it's a book about his life and back in those days, what he did and how he did that. So that's I like to read about those kind of things.
All right, so that I was going to say, is that the kind of book that you like to read, or a nonfiction about
Definitely.
science? Oh, very industry
Yeah.
specific. I like it. I like it. All right, so today we're going to be talking about maintenance. So the way I got turned on to Tobias was I actually saw him on LinkedIn, and he's written a couple of different articles in regards to maintenance and taking care of your facilities and how you deal with your equipment, the facility itself, on a short term, long term basis, looking at cost to own, things like that. And I can't remember I think it was Pharmaceutical Engineering, maybe, that you wrote it for. Pharmaceutical Online, I apologize. And so that's where I originally had heard about him. And I thought they were good. And this is a topic and just a realm that the people that I interact with all the time, and I think most of the people that are listening to this podcast really key in on. It's super important to them. And so I thought, hey, let's get them on the podcast. So I want to start with just a little bit higher end view of this before we drop down into the maintenance and maintenance 4.0, as we're going to talk about it. So there's all these different labels within working groups, the ISPE and USP and the European Pharmacopoeia, all these different groups. So we're going to start with Pharma 4.0. So Pharma 4.0 is the most recent iteration of this. It's a term that they use with this special interest group with ISPE. Could you tell me a little bit more about what we are talking about when we use that term, Pharma 4.0?
I can definitely do. So Pharma 4.0, like all the other terminology, Industry 4.0, Maintenance 4.0, is a maturity model. So they start with one and they move along. And in the case of Pharma 4.0, you can say that it's the visibility, it's the transparency in everything that is being done. It's the predictability of the systems. And in pharma, that's a little bit of a challenge sometimes, because pharma by itself is a little bit conservative in taking on board a new technology. And that's what you have now with 4.0, that the automation side of business, both on the business side as well as on the operation side, needs to enhance in order to make Pharma 4.0 a reality.
So is this, I'm just curious, is this following the same kind of progression like other things where you have 1.0, 2.0, 3.0, 4.0, but it's like getting faster and faster for each iteration? Or does it follow more of a schedule, like every 3 or 4 years there's the working group and it comes up with a new one? How does that work? Do you know?
Well, the way it works is that it's the maturity of industry to deal with the topic. So Pharma 1.0 was the mechanical way of working, that you brought together a product and you worked on it mechanically and made something out of that. And Pharma 2.0 is when electricity came along and you didn't need manual labor, but you could use tools and equipment to make your drug products. In Pharma 3.0, you went to digitization, so the first steps into using computerized systems. And now with 4.0, you go one step further, where you look at predictability, or even a little bit more than that, in terms of having computers programmed to follow certain sequences in order to deliver the products that you have designed yourself.
Okay. All right. Excellent. So we're going to move to talking about this maintenance 4.0, and like you said, there's basically all the 4.0s. So how does the maintenance 4.0 fit into the Pharma 4.0 framework then?
Well, it fits into the strategic asset lifecycle part of the business, where you design a facility and then you maintain that facility throughout its life cycle. And maintenance is basically the glue between operational activities that you do. So you make a batch, or you make a number of batches, and then you have a maintenance intervention, and then you make more batches, and you have again a maintenance intervention. And during those interventions, you make sure that you keep the equipment and the facility, the utilities, all your instruments at a pristine order, so that you are very, very confident that you can produce what you're expected to make.
So as we look at the, if we had your article pulled up here, which we don't, you break up maintenance 4.0 into 5 core aspects. So I'm going to just
Right.
walk through those really quick, but you break them down into 5. The first one is periodic inspection. The second one is
Mhm.
prescriptive maintenance. So periodic meaning we're doing maintenance on some, interval from a time perspective. Prescriptive maintenance meaning there's these things that we know that have to get done, right? On a piece of equipment. Preventative. How
Yeah.
do we differentiate between prescriptive and preventative maintenance? So those are two that are to me and sound similar. So what are the differences between those two?
Well, the difference are really significant, because you have your periodic inspections. You need those because those are your eyes and ears of your facility,
Mm-hmm.
and computer systems nowadays can record all that data,
Right, right.
and based on that, you can predict what will happen at a certain moment. For instance, a bearing has a certain characteristic, and in that you can see where or when it will most likely fail. And if you see that early enough, you can schedule an intervention so that you don't have to wait for breakdown and
Mm-hmm.
rush into the matter in order to replace it. With prescriptive maintenance, you go even one step further and you say, I've gathered so much data about this maintenance intervention that I not only know what to do, but also how to do it. And I can prescribe to the maintenance technician what it is that he needs to do to take the unit out of service, to maintain the unit, and to bring it back into service. And by doing so, you take out the variability that you may find if you have different technicians work on the same maintenance intervention.
Okay. And then the
So
next
the
one is
prescriptive side,
okay, keep going. Sorry.
there is not yet the next one. So the prescriptive one is going the farthest along.
Yep.
You've got the descriptive one. There you describe what needs to be done, and there's a significant amount of human input to make a decision what needs to be done and which actions to take. You've got diagnostic. You monitor your organization, and you have less human input because the monitoring helps you there. You make your decision and you have your actions. There is the predictive. Then you monitor a certain condition, and based on that condition, you take action, and you have your prescriptive, and there you have optimized basically the monitoring, the condition guarding, and the execution of your maintenance intervention.
Okay.
If you now would go to a maintenance technician and you would ask him to take out a filter or to take to replace a bearing or a roller of some sort, he would have his own sequence of steps to take in order to do that. Of course, he would look at safety and securing the equipment, and then he would unbolt and he would replace the unit and he would bolt it back again and he would start it up. And with the prescriptive way of looking at it, he has much less choice of how to do it because it is prescribed how to do it.
So the process by which you do it, not just say go change that thing, he actually has a process that he's supposed to follow in order to do that
Right.
that maintenance item. Right. Okay.
Yeah, and we can only start doing that today because it is virtual reality and augmented reality that helps the technician to see the unit and to know what to do in which sequence.
So I'm just curious, how big of a change is that from what it was in the past? I mean, was it more just like this guy's real mechanical? He's good at this kind of stuff. Go get it done. I mean, was that normal at one point and it's progressed to the point where it's basically a checklist. This is the step, this is the step, this is the step, to where you make sure that anybody that's going to do this item does it the exact same way. Has that changed a lot, say in the last 10, 15 years?
Yes, it has, because technicians come from school and they've learned the basics of all the mechanics and all the engineering. And then they are exposed to certain types of equipment and installations, and they get training by, for instance, the suppliers of that equipment and installations, and they explain them how to dismantle and to build back together again that installation. And then over time, what they do is they add their own expertise and knowledge to that. But everybody brings in different expertise and knowledge. And when they have to do it at night or during the shift, they may do it differently than it was prescribed because they think it's easier or faster or something like that. And in doing so, they differ in the end result that comes out of that.
There was an interesting thing. I had a training a number of years ago, and it was they talked to the subject of common sense, right? It's this, everybody talks about who's got common sense. And it was an interesting way of thinking about it. But this guy basically said, common sense is only common sense to those who know it already, right? So you have, when you have like that prescriptive maintenance, you've sort of ingrained a common sense, right? Put it in writing on a piece of paper so that everybody does it the same way, and that way you're not relying on the common sense of one maintenance guy versus another guy to do it the right way, right? And in my world, I'm in the water world, and sampling is a big deal in water, right? And because we want to get good samples, and if you just say, "Oh, can you just go get a sample?" Right? That's a bad idea if it's you're trying to avoid getting bacteria counts in your water, and you will get all kinds of results if you just say,
Right.
"Here's a bottle, go get a sample of water." Right?
Right. And the reason why the example that you bring is really good is that like 30 years ago, it was very common for somebody to work at the same facility for a lifetime.
Mm-hmm.
Nowadays, young people coming to work, they may stay in a certain position or even at a certain employer for a couple of years, maybe five or something like that. And then they will move on to the next company or to the next opportunity. And for this reason, also, the prescriptive activity is very essential because it allows you to train and educate an individual in highly technical systems quick and fast and in a good manner. And then your
Mm-hmm.
consistency in employing that asset is very high.
Excellent. So we started down this path talking about these core aspects. Now, one of the things I'm interested in is there's all these different elements of a maintenance program. Not like all of them are important. There's none that are, the only one, right? So where do you see in a lot of facilities as being the largest upside in maybe one of those aspects being ignored more than others, or one of those aspects just not ingrained in a culture? So do you see one that's a larger upside than the others when you visit a customer?
Well, yeah, when I am with customers, I see particularly with the existing facilities that the periodic inspections are too little and too small. So there's a lot of equipment and instruments nowadays, but the data from those instruments are left on computers or on pieces of paper, and they're not taken to the next level where they're analyzed in order to help, for instance, expand the lifetime of a filter bag or the lifetime of a bearing or the exchange of oil in a gearbox or um, those kind of things. So
Mm-hmm.
there's a lot of measurements that are being done. For instance, if you take environmental monitoring, temperatures and humidity are registered continuously because they're important for the batch record. But a lot of the equipment that is being used, there's a few and little measurements done on it to say something about the condition of which that piece of equipment is. With the more modern installations, that's obviously a little bit better, but still, there's a lot to gain by analyzing that data more regularly, so that you really can make decisions on what the data tells you.
So it brings me to my next question. When we talk about maintenance 4.0 and everything's digitized, right? Some of the smallest components now have sensors or something digital attached to it. So the data
Mhm.
set that we're talking about seems to be just growing exponentially, right? So before, that same, gearbox with the oil in it, you know, the way you might the way you might analyze it is to, take a sample of the oil and look at it, right? Or put it on a put it down on a surface to see if you see any particles in it, or what. There's a million ways, or push it through a filter and see what it catches. And now they have multiple sensors on that piece of equipment analyzing things all the time, or not analyzing, but collecting data all the time. So though honestly, it seems overwhelming. That's not my job. I don't have to worry about that. But how do companies, especially existing companies where they're always transitioning, upgrading, things like that, how do they prioritize that data for like good use moving forward, rather than just they get the new thing to replace the old thing, and they just treat it like the old thing? Like, how do they not end up doing that? Because they want to be able to use this data for positive maintenance and positive care of their facility moving forward.
Right. So if you have a reliability function within the maintenance team. Typically, the reliability engineer will look at the data and will help the technicians to make choices there. And of course, you have a lot of data that you collect, but if you do then a trending analysis and a variance analysis where you show that the trend is very stable over time and the variance is relatively small, you can take an approach where you don't measure every 15 measurements per second, but that you reduce that, for instance, to one measurement per second. And those are the kind of things that will help you to still have a good number of measurements over time and not overload your system with unnecessary sequence of data sets. And this also helps by making decisions again on a filter, because if the filter pressure difference over time stays stable, then there's no need to replace it. And if it goes up, then it shows you with the linear progression, for instance, that you have to replace it in a couple of weeks or a couple of days, and you can schedule that.
How have you seen? Have you seen with any of your customers that transition happen well, or is it a fight? Is it a big deal to transition from I change that filter every quarter to I change that filter when the pressure differential tells me it's time to change that filter? Like, is that a hard change for customers?
It's a very hard change for customers, and that's for a number of reasons. One, obviously, is that the pharmaceutical industry by nature is a little bit conservative. So if something works well, we're not quick to change it. The quality department that does the quality and regulatory oversight, they want a kind of position paper where you explain why you want to leave your old way of working and move to the new, and how that doesn't deteriorate the degree of quality that they expect. And here is where you have the big challenge, because in order to demonstrate that, you have to go through and make the changes to show that there is no difference, or that you have good control over it. And this you have to do then with the non-critical elements in your manufacturing facility, in order to write that position paper for the more critical elements where you make the better benefits.
Okay. So do you, if you were looking to do this in a facility, do you start with less critical things because it's easier to do it? It doesn't impact the quality and things like that, or does that matter? Maybe because the gains you would see in some of the more critical things is important. Do you have a way of looking at that?
Yeah, you would make a risk assessment where the product contact or the product impact would be the least, in order to demonstrate what it is that you try to accomplish. And then with some financial calculations, you can also demonstrate that not replacing filters every 6 months or 12 months gives a financial benefit in terms of materials used, but also less downtime, which creates in a sold out facility more revenue. And it's those kind of calculations that help the business side to understand why it is a sensible way to go forward. And with the measurements, you can convince QA that there is no risk, and that you have an eagle's eye on the situation, so that if it would deteriorate, that you're early enough to intervene.
So have you seen this be more of a culture? Is it a culture change issue that makes that happen? Do you end up with like a domino effect as you start to do it with few things, it gets easier and easier? Or is it like a laborious thing for every different process or every different type of, say, instrumentation that you might need it on, or things like that? What have you seen there?
It's really human dependent.
Okay.
So if you have a group of people that are okay to try new things and be smart about that, then demonstrating it and building on that works very well.
Mm-hmm.
And if you have the really older facilities where they've done things for like 20 or 30 years in a certain way, you really have to fight all of them in order to demonstrate the new way of working.
That's a good time, I'm sure. So in that regard, one of my questions was talking about existing facilities versus new facilities. When you talk about sort of where we're going from a data set and looking at everything. So in an existing facility, I would expect that the culture is one of the big things you'll end up having to overcome to do a lot of this change. However, in an existing facility, you have a lot of history too. So when you're talking about developing new ways of doing it, they have a data set, right? That they already know how long those filters. I'm just going to keep using the filter thing. They already know how long those filters last, practically speaking. So they have a lot of go bys. Versus in a new facility, you might be able to come in right over the top and sort of come in with the culture, but you have no history to base anything off, and so you're kind of coming in cold. So what's that been like for you in an older existing versus a new one with maybe this new framework of maintenance? How do you see that moving forward? And what I said, does that make sense? Am I in line there, or am I making that up?
No. You make a lot of sense. But the nice thing is that with the most new facilities, you bring in not bad. Sorry for that. You bring in old
Yeah.
habits, and that's because a lot of knowledgeable people come in from other facilities, either within the company or even from external, and they will build a new facility. And they bring a backpack of knowledge with them and experience that they can't really substantiate, but they will say you have to replace the filters every 12 months or 6 or whatever. And if you then ask them, have you ever tested a filter after you've taken it out, what the pressure differential, the residual pressure differential was when you replaced it? Most of them, if not all, will say, no, we don't have time to do that. And this is where you can make your benefit. So one way to go in there is when you do your regular maintenance, as you normally used to do, that after you've done your maintenance, that you check the replaced part, and this may be a filter or a bearing or whatever, and you look at the residual quality that's in that part. Because an example, if you take an automobile, back in the 70s, you had to replace the oil every 5,000 miles. And nowadays, you can replace oil every 30,000 miles. And they've done that through a number of things. But one of the more important things is that the fitting of all the bits and pieces that make an engine are now so well attuned to each other that there's less wear and tear. And this is also with a lot of equipment nowadays. It's much more accurate, much more precise, and the wear and tear is a lot less than it was 20 years ago. So your intervals can accommodate for that, but you have to demonstrate that somehow or another. And the first step that you could do in order to do that is by taking the part out according to the schedule that you have been given, and then measure the residual quality on that unit and demonstrate, for instance, that still 50% of its life is left, or even 70%. And then you can go into and argue that keeping it in there a little bit longer doesn't deteriorate the quality of the product that it needs to make.
Yeah, and that incremental change over time proves out the idea of it, right? I assume you don't make large changes generally. You would make smaller changes that are safe still.
Yeah.
Yeah.
And you can see that, for instance, in statistics. You have AQL, acceptable quality level, and there you have a tightened, a normal, and a reduced schedule, where if you don't find faults in your AQL, you're allowed after a little while to go to the reduced schedule and take a larger interval or a lesser number of samples. And if you then find a failure, then you beef it up again, or you beef it up even to the tight schedule. And this is what you do also in your maintenance activity.
Right. Well, it's an interesting It's an interesting problem. It's like a technical problem. It's a very factual problem, and then it's a people problem as far as how you manage expectations and how you get those changes made. So, because I could tell you, I'm certain that I know plenty of people that still think you have to change your oil every 3,000 miles. So that hasn't been the case for a long time. Um, so as we get
Right.
we get in towards the end here, I'm curious, like if you were to go in and speak with a new client and you're wanting to talk to them about some of these kind of things, um, where would you begin? Like this is kind of it's a huge thing, right? There's no one place or one. So how would you begin the process, or maybe they're at a point right now? What would be how you frame this talking to a new client for moving forward and getting to that next level maintenance 4.0 in that larger framework?
Well, what I would do is I would probably start with the sore point that they may have in
Mm-hmm.
maintenance, because uh, typically the manufacturing operation, they will finger point to maintenance, saying that they don't do a good job in keeping the equipment upright, or they take too much time to do that. And those are the access points that you have for conversation, where you could say, well, we could do it differently.
Mm-hmm.
And then you can come into a conversation and take some of those particular examples that they have in terms of the awkwardness that they feel in how long it takes to do a certain intervention. And filter replacement in HVACs is typically one, because whole bits and pieces of the facility need to be shut down, and they can't get to the clean rooms and stuff like that. So those are good entry points to start have a conversation with the ops manager or with the manufacturing manager,
Mm-hmm.
that it can be done differently if they are willing to walk the path with you.
Well, this is it's a fascinating topic, and again, I think this is one that it's important to every single facility that we go into. Everybody is at some place right now, right? Nobody has made it, right? And if they have made it, then they're just going to
No.
be the guys that help define maintenance 5.0, because they're gonna figure that out. Um, and I think it's something that we always have to be pushing and finding new ways to have that conversation with, like for me, with my customers or with your customers, the people that we see every day, to help them better approach these problems so that they can care for their facility and care for their equipment, and better, to make it last longer and perform better, and ultimately be able to make a medicine that is it's safer for the customer. It maybe it's safer, or it's it's just more fine tuned, and it's more of what it's supposed to be, right, as we deliver it. So I think this is going to be something that we continue to see, just increases and leaps and bounds over the course of time. And I see it. There's just an example of this. I have a customer where I'm at, and they've been doing vibration analysis. I don't know if you've seen much of this, and I don't even know the name of the equipment, but they can stick this thing and they point it at this piece of equipment, and they can see the tiniest bit of vibration, and they can track it over time, right? They'll do it one day, and then 3 months later they do it again, and 3 months, and
Mhm.
they can see with this delta over time that the maybe what comes with the equipment doesn't even register it, right? Because it might have just an alarm when it gets to a certain vibration, and like, oh, this is a problem, you gotta fix this.
Mhm.
These guys can see on the super micro level, little bits of vibration getting bigger, so they can start to predict when it's going to get to that point where maybe it would be alarming on the equipment itself. And see, and as they do it around the facility on different pieces of equipment, they're starting to find similarities between this kind of equipment and this kind of equipment. How do they mount motors, and how do these guys mount motors? How do they, all that kind of stuff? And they're able to really start to get a feel for um, better ways of doing things that I think even the manufacturers maybe don't know, which I think is pretty interesting. Have you ever seen that?
I have, yes, with really large machines in the
Mm-hmm.
packaging industry, where vibration analysis is used for very large bearings that are very critical to the process, and where things like misalignment and wear and tear are things that you really have to find early on. Otherwise, the consequential damages are huge and big.
Mm-hmm.
So definitely yes. And vibration analysis is a nice example of that. With vibration analysis, you do it with an equipment, but that also is with sound and noise. If you have your
Mm-hmm.
operators be sensitive for the sound and noise of your facility, they can already hear certain noises that will lead to damages in the not too distant future. And if you have them talk
Yeah.
to the technicians and say that, then you can avoid corrective maintenance requirements at all hours in the week. And one other point that I would like to make, the reason why facilities need to go to Pharma 4.0 or Maintenance 4.0 is also for demographics. It's becoming more and more difficult to get enough staff to do all the work that you're supposed to do. And in order to do it properly and get people trained, you need to have a different way of working and a different mindset to your technicians and your engineers than maybe 20 or 30 years ago.
Mm-hmm.
And this is where companies need to prepare themselves that even in 5 or 10 years' time, they still have enough staff to do all the work that's supposed to be done.
That's a great point. I guess I didn't connect the dots when we were talking about it, but that's a really great point for. I mean, it's really almost any industry right now, but we're not talking about any industry. We're talking about the pharma industry, and that so many places maybe used to have a whole bunch of good utility guys that all had lots of capabilities to be able to say, hey, go fix that, and they would go and fix it, right? But the budgets come down, and they don't have the time, and they have uh, far greater responsibilities on a daily basis. They could never do all that, so like you need to have everything set up so that the guy that really doesn't have that capability could actually go and do it. Or you're predicting all this stuff so that that problem is that much less likely to ever rear its head in a catastrophic way. So that's a great point. And again, that's something that I run into, and we hear, oh yeah, we want this new system, and we won't have anybody to work on it, so we need it to be connected so that you guys can log in and take a look at it right from a distance, because I won't have anybody there. I'm like, oh,
Yeah.
okay. It's kind of an expensive piece of equipment, but sure.
Yeah. And that's a nice point that you're making, because with the connectivity, you have to take security into account, that you can only have the outside company connect into your installation
Mm-hmm.
when you want it to, and that otherwise that access point is not connected to the internet, because that's the backdoor for phishing into your system. Simply because the ARP system that companies use for their business over the warehouse management system typically is connected with electronic batch records and stuff like that. And
Yeah.
that means that some of the equipment in your facility is connected to your business computer on the office side. And people will find ways to trail back into that system and, make real issues like with the oil pipe that recently surfaced.
Yeah, and while I'm very, very aware of what you're talking about, you are completely over my head at this point. I know nothing. Uh, I'm not a hacker. So, well, hey, this was really good. I really like learning about this. Again, this is my world. This is the people that I interact with on a regular basis. So I think this is important to talk about. Um, so as part of any of my podcasts, we always make sure that people can get in touch with you. What's the best way if somebody wanted to reach out to you, say hi, learn more about what you do there? What would be the best way to get in touch with you?
Well, they can probably easiest find me on
Mm-hmm.
LinkedIn. And if they go to the journal articles that you mentioned at the beginning of the podcast, they will find an email address there also where they can reach me. I've got a cell phone that they can call me, and I'm available to each and every one of them.
All right, awesome. So, just like normal, we'll make sure that all those links are in the podcast notes, the YouTube notes, and you'll be linked on LinkedIn when this goes live eventually. So, I will make that as easy as we can for people if they want to get a hold of you. But hey, I just want to say thanks so much for being on the podcast today. This was great. I hope everybody else is able to learn more about Maintenance 4.0 from this, and maybe read some of your articles while they're at it, because they can get a little bit additional different insight that we weren't able to talk about today. So thanks so much for being on here today.
I appreciate it for the invite, Jesse, and look forward to the next time.
All right. Awesome.